Hello, you all. My name is Saurav, and you welcome to my YouTube channel. So today we are going to discuss pretty much important topic of statistics. That is also one practical of computer science students. That is first year computer science students. In that we will discuss how to generate the random samples from a particular distributions. Okay, or of a particular distributions. Now here we are considering the three basic continuous probability distributions. Okay, so the first distribution is the we are considering it is a uniform distribution. Okay, so this here you can see clearly see that is the this is the first question. Okay, which is of the uniform distribution. Now the second question is of again the uniform distribution. Okay, that means the first two examples are of the uniform distribution. The third example is of the exponential distribution. The third and fourth is of a exponential distribution, and the fifth and sixth is of the normal distribution. Okay, right? So we will just start. Okay, तो चलिए हम लोग शुरू करते हैं. Now here we have to generate firstly the random numbers. Okay, okay. So now here this first after the serial number, the second column we can see that is nothing but the random number. Here what we are doing, it is not these random numbers are not any particular type of the distributions, right? So these are just the simple random numbers we are considering. And after that we are converting these random numbers into the uniform distribution, right? So what procedure we have to do, that we have to study here. Okay, so here we will just use one formula for generating the random numbers, that is nothing but the equals to, okay, rand. Okay, this function is basically used for, okay, generating the random numbers, and we will just close the bracket. Okay, and we will just press the enter. Then here the first random number is getting generated. Okay, now for generating the getting the order, right, from 2 to 10, right, all the random numbers, we will just drag this, so here we will get all that random numbers. Okay, so here we got that all the random numbers, right? Now here we have to fix these random numbers. Okay, right? Now to fix these random numbers, so what we will do, here we will just copy this all the random numbers, right, for fixing the random numbers. Okay, and here for pasting, so we will just right click and we go to the this option, that is paste spatial, and from that we will click on the values, right, and then click OK. Now here we got that all the fixed random variables, here we got that. Okay, after that, now here this is your final random samples. Okay, that is the, now this will be your random sample of the uniform distribution, right? That is your next, that is final column. Okay, now for that purpose what we are doing, we are just trying to use these parameters of the uniform distribution. What is that parameter, which is nothing but the minus 5 and 5. Now you know that what are the parameters of the uniform distribution? It is uniform A and B, right? So that's the reason we are using this formula, that is x is equals to a plus b minus b star into f of x. Okay, and this sample size is nothing but the small n, right? That means here my values of a is what? A is nothing but the a is equals to the minus 5, right? And my value of the b is equals to plus 5, right? So this is the value I am considering. So my formula will become what? It is minus 5, right? Minus 5 plus b minus a, right? So it will become 5 minus minus, this will become plus, that means it is 5 plus 10 star f of x, right? So this is the formula I have to use here. So simply I will just use that formula, right? So it is minus, right? I will just firstly, for using any kind of the formula, we must we have to must start with the equal to sign, right? So equals to minus 5 star, sorry, minus 5 plus 10, right, star f of x, right? Now here my f of x means what? My these values, right? These values are basically called as the capital F of x, right? So in this column, my first f of x is this, so I will select this value, right? That is my capital F of x, and I will just simply enter that value. So here I am getting my first value, that is 2.216811193, right? That is my first random sample, right, of the uniform distribution. And again I have to just, now I have already just given the formula to that particular column, right? So I will just simply drag this and then I will get the all the random samples, right? Now here remember this one guy, one thing, that is nothing but the, you can see all these values, right? It is lies between minus 5 to 5, right or not? Because it is following the uniform distribution with parameter minus 5 to 5. Okay, hope you understand these examples. Why it is following, right? Why it is under this values? Because it is following that particular distribution, right? Minus 5 to 5. And here all that value are between minus 5 to 5. That means our answer, right, or the random sample we have generated is the are the correct. Okay, so we will go to the next example. Now this is again the same example. Here it is again the uniform distribution, the same formula we have to apply. Now what is the question? Okay, they have given that, that is the PMT bus scheduled to arrive at a bus stop at 8:15 a.m. arrive anytime between the 8:10 a.m. to the 8:20 a.m. and we have to simulate the arrival of the bus times in the 30 days of the time. That means here our value of the small n will be what? Our small n will be equals to the 30, right? Now here your a, the value of the a will be what? That is the value of the small a. So small a will be what? It is nothing but the 10.10, right? Sorry, 8.10, right? 8.10. The value of the small b will be equals to the 8.20, right? So these are my two values of the a and b. That is the my values of the parameter. Okay. So that's the reason if I apply this uniform distribution, so it will become, right? That means my final formula will become what? It is a, right? A means what? 8.10, right? Plus b minus a, right? That is, now here it is. I have done this mistake. Okay, it must be plus, right? B minus a, right? So here the value must be plus. Okay, because the formula here it is a plus, right? So here it must be plus. Okay, plus 0.10 into f of x. Okay, firstly I will just check the value whether I am correct or not. A plus b minus a. Here it must be, it is plus 0.10 into f of x. Okay, okay, so we will firstly do that. Now yes, now this procedure you already know. Firstly we are generating all the random numbers, so that is rand of this. So here you will get the first random variable, so we will just simply drag this, so we will get all the random samples of the 30, right, 30 observations, and we have to fix this. So how to fix this? Firstly select that, right, and after selecting this, what you will do, I will copy this and go to the paste spatial and paste like this, right? So this is your fixed random values, right? Now simply use the formula. That's why it is equals to what? A means what? It is 8.10, right? The value of the a, plus 0.10, right? Why it is 0.10? Because here it is b minus a, right or not? B minus, so which is 8.20 minus 8.8. Start into f of x. F of x means what? This value, right? So here you will get this value, right? It is 3.8.30, right? 16, 18. Now here also this value is lies between small a and small b. That means now here it is following uniform distribution. Okay, it is uniform distribution which follows the parameter what? 8.10. Sorry. Yes, 8.10 and 8 point what 20, right? Yes, so this is that particular distribution is following, and here your value, if you try to observe this value, that is first random sample, so it is between these 2 points, right? That means 8.10 and 8.20. Okay, so I will just simply again and drag this all the random samples. So here I get all that random samples, and you can clearly say that that is my all the values are lies between these two particular random, that is particular parameters. Okay, so this is how I generate the random samples of the uniform distributions. Okay, I hope you get this. After that, we will see now the next thing, that is nothing but the random samples of the next distribution, that is called as the exponential distribution. Again, how to generate the random samples of the exponential distribution. Okay, so for that purpose, now the this procedure is again same. Okay, that means these two columns, as we did here in the previous examples. Similarly, we have to again generate these random numbers and fix random numbers by as we did in the previous examples. Okay, now here, uh, now remember one thing, guys. Okay, in these first two examples, there is no need to you will get the same random number, right? As like me, right? You maybe get some different random numbers also. Here also you will maybe get some different random numbers, but there is only one condition. That means if you have to check whether my answer is correct or not, or whether my generated random samples are correct or not, you will just simply go to the, okay, you will just simply check whether this observation or lies between that parameters or not. If it is lies between these two things, right, that is minus 5 to 5, here also between that 8.10 to 8.20, then you can simply say that right, my answer is correct. Okay, so this is the simple thing to check, right, whether it is correct or not. Because you know, if you try, if any other different student is solving, then he may get some different random samples also, right? Here it is 8.30 for you, but for the other another person, here it may be 8.70 or 8.18 for any other students, right? Okay, so that is the one thing to remember. Okay, now we will see how to generate the random sample of the exponential distribution. So firstly we will just complete this procedure. Okay, that is firstly we are generating these random samples, right? And yes, and we will just fix that, right? Now here our the value of the small n is what? Okay, firstly we will just read the question. So what is the question? The length time of a person in the company follows exponential distribution with mean 4. Okay, simulate the series time for a person and obtain the probability that person is served is less than 3 minutes, right? Okay, so that is the thing we have to calculate here. Now understand one thing, that is they have given you that is exponential distribution follows the mean 4. Now for that purpose you must know what is the distribution, right? What is exactly, what is the parameter of the exponential distribution? And what is the mean of the exponential distribution? What is the PDF of the exponential distribution? Right? So yes, maybe the formula PDF mean is occurring on the screen. Okay, so here your exponential distribution, the PDF and the mean. Okay, firstly it is following, that is the x is following. That is we are firstly seeing what is the parameter of the exponential distribution. Okay, when x is, that is we can see, or we can in mathematically or symbolically, if x is following the exponential distribution, then symbolically we can write it as, that is x is following exponential, okay, 1 by theta, right? 1 by theta. Here theta, firstly I have to select that symbol here. Okay, just understand guys. Okay, here it is theta. Theta. Okay, so this is how you can denote symbolically, right? Whether x is following, uh, right, that particular distribution, right? This is how you denote. Okay, and that's the reason your mean of that exponential distribution will be what? That is the mean will be equals to what? It is equals to theta. Okay, it is theta. All right. Okay, so this is the mean of the exponential distribution. Now here again, we will just fix our random numbers. Okay, sorry, here I don't need the, okay, now go to the space spatial, then values, and then okay, okay. So this is how you fix the random variables, right? So simply here again, just use the formula. Now, right? Now if your mean is theta, then your simply the mean will be what? In this case is what? 4, right? That means the value of the theta is 4, right? Here it is, you can put that value 4. Again, just use this formula, right? So what? That is equals to what? Minus 4 star. Here it is, you have to take log, right? That is ln of 1, right? Minus f of x means what? This value, and bracket complete, and just enter. Okay, so this will be your random sample for that, and just drag these values for all the 20 observations, right? So this will be all your random samples for the exponential distribution. Okay, so what we will do, we will try to check the mean, right, whether it is approximately equals to 4 or not, right, of the random samples, right? Then we will see whether our example is correct or not. So here we will just go to the average, and here it is 4.80 something, right? So that means we can say that, right, it is approximately equals to 4. So we can say that our random samples are the correct. Okay, that is 1 minus, whether I've used the right formula, right? It is 4 minus 4 into ln of 1 minus f of x, right? Okay, so this is the procedure for finding or generating the random samples of the exponential distribution. Simply we have to use this formula. Okay, no any difficulty in that. Okay, so again the question number 4. Again here it is the example of the exponential distribution. Okay, and here it is taking the mean to, and also find the median of the sample. Okay, here we have to find the median of the samples, right? Right, so again just use that equals to what? Rand of rand of what? Bracket close. Okay, Now here there are total size is what we have to select the samples of size 20, right? So just drag that all 20 samples and then again fix that random number. Okay, so how we can fix that random number? Yes, we will just copy that and go to the special values. Okay, right? So this is how you fix the all the random numbers, right? Now here again, just use the same formula here. Now here the value of the theta is 2, right? It is equals to minus 2, right? Star ln of, oh sorry, yes, ln of 1 minus this f of x. Okay, so that's the reason this will be my first random, right, sample of that particular distribution, and this will be my all the random samples of that exponential distribution. So I will just check, right, whether it is correct or not. So I will just check whether, so find out the mean of that, right, and it must be approximately equals to 2, and here it is 1.67, which is approximately equals to 2. So we can say that this is these random samples are the correct. Okay, that is all the random samples are the correct in these examples. Now here also we have to also find the median of the sample. Okay, now how to find the median? Okay, so simply we will use one formula. Now here I think I have already defined it, that median. Okay, yes, I have find it that median k85 divided by 2. Perfect, perfect, perfect. Now understand this. Okay, now how I find it this. Firstly, there is one simple thing is there for finding the median. Okay, we will use we will use what? Firstly, I will just clear this everything so that you can understand this properly. Okay, so I will use the formula. Okay, here is just a simple function in the Excel is there for finding the median. I have to find the median of what? These samples, these all samples. That is equals to, I will just use equals to what? Median, right? Median. Now here it is median curve, which is written as the median, right? Now here in the function they have given the information about that particular function. Okay, median of what? All these numbers. Okay, and I will bracket, close this bracket and enter the value. So which is 0.925838, right? So that will be, this will be your median on that particular thing. Okay, now we will try to use one formula of the median. Now what is the median in this case? It is nothing but the middlemost observation. Okay, median is what? It is the middlemost observation. So for that purpose, firstly we have to arrange this observation into the ascending order, right? So what I will do, firstly I will copy this all the random samples. Maybe I don't know, after pasting it will be changed or not. Yes, it will be changed, right? Right. So just remember this thing, guys. Okay. For generating these random numbers, we are just using the one thing, that is nothing but the just one simple formula, that is equals to median of, just select that all values and you will get the median of that particular thing. Right. That is all the particular samples. Okay. So this is how you get the median of that random samples. Okay. So this here we have covered the random samples of the uniform and the exponential distribution. Now the next thing, that is the question number 4 is what? Question number 5 is of generating the random samples of the normal distribution. Yes, so we are seeing the how to generate the random sample of the normal distributions, right? Now remember what is the difference between the normal distribution, okay, for generating the samples of the uh, here that is for generating the distribution of the that is random sample of the distribution in any other distribution and the normal distribution. So the difference is here, right, in this particular, that is in the uh, we have seen the uniform distribution and the continuous sorry, uniform distribution and the exponential distribution. Here we are using this as, that means we are denoting this as the capital F of x, right, and we are using this capital F of x here, right? That means we are using the distribution function, right, in the exponential distribution and the in the uniform distribution. But here the here we are not using the distribution function, right, in the normal distribution. Okay, so there may be some reasons for that. Here we are using one method that is called as the Box-Muller transformation. Okay, it is called as the Box-Muller transformation. So in this method, what we are doing, we are firstly generating the random numbers, and from that, after getting this, right, after getting these two fixed random numbers, we are calculating the value of the x, and from that we are finding the value of the y's. Okay, so this is the method for that. So we are just go with the process now. Yes, so firstly we were just generating all the random numbers, so which is ran of these. Okay, and just drag all that. Now here, how many observations are there? We have to simulate income of the 15 employees, right? So just drag that, you will get the all the random numbers, right? Now here, for finding u1, what you have to do, you have to just copy this, right? And again, as we did in the previous examples, right, go to the base special, go to the values, and you will get that all these things. Now here also, just go to the base special, right, values, and all these, right? Now here you will get some different fixed random numbers are there. Okay, now we have to use this formula for that. Okay, this is called as the Box-Muller transformation. Okay, the formula is what? It is the square root of minus 2 ln, right, u1 into cos of 2 pi into u2, right? Now here we are taking the value of the pi is something 3.14, right? Here pi is equals to what? Pi is equals to 3.14. Okay, what is the exact value? Here I have given that value or not, right? So it is 3.14152. Okay, so that value I have to use here. Yes, here it is given. Okay, it is 3.14152. 14152. Okay, so this value which I have to use for the pi. Okay, yes, I will just go with the procedure now. So right, so this is nothing but this is equals to the square root of, okay, minus 2 into ln of what number, that means what, first number u1. Okay, bracket close, right? So this will be the square root of this term. Okay, that is minus 2 into ln of u1, right? So I will again close the bracket, right, and multiply by what, cos of 2 into what, pi. The value of the pi is what, it is 3.14152, right, into what, multiply by what, the next value, that is nothing but the u2, right? 2 into pi multiply by u2, that means this value, that is the next fixed random variables, and just close the bracket. Okay, and here you will get that value of x, which is equals to what, minus 0.269984. Okay, now again just generate, just drag that, you will get the all the random samples. Okay, right, so that is nothing but the of all these random numbers, you will get all the x. Now here this is your final random samples of the normal distributions, right? So what that here the value of the that is y is equals to mu plus sigma y, right? And value of the mu is given. The mean mu of the normal distribution what? It is 6,000. Okay, it is 6,000, and the standard deviation is what? It is denoted by sigma, and it is 500. Right? So we will just substitute here, that is 6,000 plus 500 into x. Now x means what? These values, right? Yes, so it will be equals to mu is what? Mu is 6,000 star, sorry, plus, right? Plus 500 star this particular value. Okay, and I will just enter that. Now here you will get the value of the 1, and you can see that it is pretty much near to the 6,000. Okay, so again just drag that all the values, you'll get the all this. So this will be my all the random samples, right? And if you try to find the mean, right, so it must be approximately near to that 6,000. Okay, so yes, it is 5,928. Okay, which is approximately equals to 6,000. So we can consider that mean. Okay, right. So this is how we generate the random samples of the normal distribution. Okay, again I am giving this example to you guys. Okay, now you can solve this example. Okay, or should I do this? Okay, I will just complete this. Okay, this is the last example of the again the normal distribution. Okay, now here again go with the same procedure, that is nothing but the rand of this. Okay, and drag that values, find out this u1 u2. What you have to do, you have to just find out the fixed values. Okay, sorry, equals not, you have to just paste that value, right? Random numbers, all the random numbers, right? Go to the paste spatial, go to the values and click OK. Again here paste spatial values. Okay, right, so here we have got the two fixed random variables. Again we will use the formula. Okay, so what I will do, I will copy this formula, right? Because the same formula we have to use here, copy, and I will paste. Okay, sorry, here it is something occurs. It's correct. Okay, okay, so I will just print this. Okay, it is not okay. Square root of what? Square root of minus 2 star ln of this number, right? uh, okay, and find out the square root of this number, multiply by cos of what? 2 into 3.14152, right? And multiply by what again? u2, right? That means the second value, multiply by the u2 means what? The second random number, and bracket close. Okay, close the bracket and enter, right? So this will be your that particular value of the capital X, right? Again drag these values, Find out the values of the y. Now what is the mean in this case? Here mean is 20, okay, and the standard deviation is 35, right? So that is nothing but the y is equals to what? Mean is 30 plus, sorry, mean is 20, okay? Mean is 20 plus 35 into what? That is standard deviation into x value is this, right? Okay, here I don't have 10 is okay. 25 into this value of the x and enter, right? Now drag this all the values again and find out the mean, okay? In this case, what it is. Now again, in this case also, you got the mean, which is approximately equals to 20, okay? So this is how you generate the random samples of the, right, all these three distribution. That is nothing but the uniform distribution, okay? Uniform, we have seen first two example, uniform distribution, exponential distribution, and the normal distribution, okay? Hope you understand this and hope you like this video, okay? If you like this video, then just share with your friends and subscribe to the channel, okay? So bye bye you all and thank you so much.
To change your